All right, so this is going to be the sedimentary rock review. All you need to do is fill in the notes that I've given you. Again, writing is a really good way to remember this stuff. Drawing, especially this little drawing that I have right here, it is super helpful when doing the quizzes, the tests, and all this other stuff. All right, so sedimentary rocks. They're formed from bits of pieces of rocks that are glued together. Not glued with like glue, but like cemented together. One thing I want you guys to look at, if I didn't already state this, page 6. I know you guys are looking at page 7 for this, but on page 6, which you should definitely highlight, is compaction and cementation. That's what gives you sedimentary rocks right there. So, like, highlight that. I highlighted it a different color. As you can see, there's my igneous rock. There's my sedimentary rock, 2 different colors so that they're color coordinated. So, first things first, we're looking at this. Sedimentary rock formation, and we're going to go say we're looking at the edge of a river or a stream that goes out into the ocean or into a big lake. So you have all this fast moving water from the river, stream, or whatever, and it's coming out, and it's got like this mixture of all sorts of different types of rocks and pebbles and sand and silt and clay, like just a huge mixture of that. And it's flowing out, and then it hits this slow, non-moving lake or ocean. Yes, I get that some oceans have waves, but say you're getting into that part where it doesn't really get that waves, and it's got this motion that goes out. Even if the wave hits, this does come into effect. And so when you hit this slow stuff, all the heavy stuff tends to drop out first. So you get like pebbles drop out, then the sand, then the silt, then the clay, and then eventually you have like living creatures, clams, shells, everything that has the shells, right? And so this is how you get sedimentary rocks. This will come into effect when we go into erosion and stuff like that. But for right now, we're looking at this for sedimentary rocks. So when pebbles fall out, remember, pebbles are just like all sorts. They're not typically jaded or anything like that. They go, especially in this, you look at the glue. The glue is sand and water. Sand is just really, really ground up. It could be shells, pebbles, and all that other stuff. All put together. That causes the glue. That's what sticks things together. And as pebbles start layering and layering and layering, you got all this pressure, and the pressure is pushing, and it compacts and cements it together so that it's forming conglomerate rocks. And then the sand, right where the sand happens, the sand compacts and it pushes, because it's got sand and it's got the water. It compacts down and cements, forms sandstone. Same with silt. Silt becomes siltstone. Clay becomes shale. And then when you have the living creatures that have the shells, that forms limestone. I'm sorry, limestone isn't written there. But limestone is made of calcite. And remember, calcite it bubbles with acid. So we saw calcite. Calcite is the calcium. Calcium is found in your bones or shells. That bubbles with acid. That's how you have limestone. And limestone actually forms caves, because remember, you have acidic rain. Acid bubbles out the calcium or the calcite that is in the limestone, so it eats it away, and that forms caves. Okay? All right. So I probably already had you guys do this. What I need you to do is just to underline the rocks that I would like you to know. There's about 7 of them. You got conglomerate, and look at this. It's like pebble pudding. Then you got breccia. It's gonna break it. It's all this angular, like broken fragments all together. Think of it like as if you had rock slides over and over and over again. It's got those broken up bits and pieces smushed and compacted together due to the rain that is cemented it. Then you have sandstone. Sandstone just looks like a lot of dots. Here's the thing that I find interesting. Look at this. You got pebbles. So you got the rounded one with dots. Remember that sand compacts things together. Then you got breccia with dots. So the smaller particles help form it together. Then you got siltstone, which has dots and dashes. So siltstone, all the ones before this had dots. And then finally get to shale, and that just has the dashes. So you have dots and circles, dots and squares, dots and lines, and lines. And then on this bottom part, you got limestone. Let me scooch this down a little bit more. Limestone looks like bricks. Just looks like bricks. And then you have bituminous coal. It is going to be black. I'm sorry, it's really hard for me to see. You'll have that black with lines in it. All right. So there are 3 types of textures, and you can find this in your reference table. The textures are all the way over here. So first you have classic, which means they're made from cemented, glued together. So this is all glued together, like sandstone, made of sand, all glued together, or conglomerate made of pebbles and sand and cobbles, all glued together. Then there is bioclastic. So think of like biology. Bio means living things were glued together. Examples are bituminous coal made from plants. Those come from like the ponds and stuff like that. Or bogs, where plants die and they kind of fall in the water. There's no movement of the water, and it just like builds and builds and builds and builds and builds, and then eventually it turns into bituminous coal. Limestone, from the shells that I just talked about. The shells pile on top of each other and they're glued together. That's bioclastic. So classic means sediments glued together, like sandstone. And then bioclastic means they're glued together, but they were living at one point. Then there is crystalline. This is where you have precipitates or evaporates, like salt water, rock salt, halite. And then you've got rock gypsum, made from gypsum. And then you've got dolostone, made from dolomite. These are all stuff that is precipitates out. That means the water had so much of the minerals in it that the minerals literally drop out because there's so much and so heavy. Or from evaporating. Think of like the Dead Sea. It is so salty that along the edges of the sea, it is all salt. There's layers and layers of salt because all that water evaporates, and because the salt does not evaporate with the water, it is left there. All right? So you have map symbols. First off, you have textures right here. You have grain size. Grain size is also very important. You can see that in the grain size, composition, what it's made of, comments. It'll give you little hints and tips of what's in there, how it's formed. You have the names, and then, of course, you have the map symbols, very important. So looking at the map symbol for conglomerate, like I said, it's a box with dots and circles. Sandstone is a box with dots. Siltstone, a box with dots and dashes. Shale is just dashes. Limestone, my favorite, so easy, looks like bricks. And you must remember that acid rain dissolves the calcite that is in the shells, and it forms caves. What mineral is in limestone? So look over at the comments. Limestone, precipitates of biological origin, cemented shell fragments. So you know there's shells or calcite in it. Rock salt. Rock salt is made of, right there. It says what its composition is, calcite, right there. Composition of rock salt, right there, is halite. Composition of breccia. So looking at breccia, you go over here and it'll tell you it's got quartz, feldspars, clay. And then grain size for sandstone. So I look for sandstone and I go all the way over here, and it literally tells me from 0.006 to 0.2 centimeters. All right, so here's a picture of the different types of rocks. So conglomerate, it literally looks like pebble pudding. Breccia looks like it's going to break you. It's all angular. It looks like if you fell on it, you'd hurt yourself. Sandstone, it literally looks like red sand. In our case, I have a bunch of red sandstone. It looked like a whole bunch of just red sand all together. And if you got a really good piece of sandstone, you'd see the different layers with the different colors or different offshoot of colors. Like you could have really red, then beige, then tan, then red. You'd see that. A siltstone could be like whitish or a grayish color, and it's just more fine and compacted than sandstone. Shale, here's the thing with shale, because you're going to come up with slate. The difference between the two is shale not be shiny. No matter which way you move that thing, it is not shiny. And it is the one rock that you will most likely find fossils in it because of how it is formed. It's clay. It's very, very particleized. So if say a shell was to fall in it and it compacted down, it would form excellent fossils. And then you have limestone. Limestone looks kind of like oatmealish, but with a bunch of shells. And then bituminous, this doesn't really show you, but it is definitely black. This is not the coal we use to burn because there's not enough carbon in it right now, or there's too much. I'm a little confused on that after looking at it. I don't think there's enough carbon in it. But when you look at it, it's kind of shiny, but at one point you can literally see the lines, how it was smushed together, and you can somewhat see it here. There's a little bit of layers. You can see the layers. Okay, so that's it for the review. Don't forget to take the quiz. If you have any questions, get a hold of me. Don't forget about Zooming with me. Besides that, I hope you guys have a great day.